I've had some wonderful questions, and while I like to try to stick to a schedule, I especially prioritize questions because they often indicate what people are really wondering about out there, and to help speak to the conditions that that people are dealing with. Often, I find it's helpful to prioritize the questions. So there was a question that came from a student that I thought could be particularly important to communicate because it's a common need, and that is so it's all fine and good with this population, with these statistics. They allow us to take, mins or maxes or counts, averages, sums of things, but suppose we wanted to do something common like compute the fraction of the population that's obese. How would we do that? And it's a little bit subtle, but this is something. So statistics and AnyLogic are circumscribed. There's many common things you can do with them, many common things you can't. But one common thing you can do with them is compute the fraction of the population that matches certain characteristics. And just because it's a common need, I'd like to deal with that particular question. So if we want to find fraction obese here, there's several different ways to do it. One of the ways is to do an average, or to do a sum here over all people that are obese. We're going to total up, suppose there's 100 people in the population. We'll count each person as being 1/100th of the population, 1% of the population. We'll total up those 1% for each person who's obese, okay? So we'll total up for 1.0 divided by the population size. This is going to be, again, 1% if the population size is 100. We would total up those 1% over all people who are obese. And now, ladies and gentlemen, we're going to sleuth down. How would we determine the count of people that are obese? Well, ladies and gentlemen, how would we tell if someone's obese in our population? First of all, what do we begin with? I mean, how do we refer to? So again, this is going to test this condition for each successive person in the population. We're going to be testing this condition, whether or not this is true, to figure out if they should be counted. In this, their value should be summed up. So how do we refer to the name of to a reference to that person, a particular person in the population is being tested? Refer to them as item. Yeah, you can see this item, the embedded object. So that's a good start. The question is, what comes after this? So to figure that out, folks, here's the thought process. How would we tell? Here's a person. How would we tell if this person is obese? Tell me where I would look if I were running this person. How would I tell if this person's obese? Okay, their color is be one thing, and if they were in this obese state, right? The color is a reflection of the state they're in. So it's really if they're in the state. Okay, that's great. So we want to ask them, are they in that state? So let's go back here. And we want to go to the population because it's populations where we define statistics, and we want to find out for fraction obese whether they're in that state. Okay, so to ask whether that person is in that particular state, it's a state in a what? It's a state in a state chart. So we have to ask their state chart, hey, are you in this certain state? Are you as a state chart currently in this state? So we need to ask the weight state chart. So again, I'm typing item dot WEI control space state chart. We're going to ask the state chart, are you in this state? Now, I'm going to put a dot here and pretend I don't know. Okay, so I do control space, and it gives me all these choices. Oh, man, look at all those choices that present themselves. So imagine I didn't know how to find out if they're in a given state. I can look through here, right? And which of these which of these choices seems most appropriate? Is it fire event? Nah, not fire event. Get active simple state? Yeah, maybe I could do it with that. Get their active state. Is it get agent? No. Is it get full name? No. Get name? No. Is state active? Yeah, that sounds pretty good. So we want to ask, is this state active? Okay? Is a certain state active? And we want to ask about a particular state. And it's going to be called person.overweight. It's overweight with respect to a person, okay? Okay, so, sorry. Oh, thank you. Obese. Thank you. Person.obese, okay? Why this person? Well, this notion of obesity is specific to the person. And if I did person dot, you could see, okay, there's obese. By the way, Kristen, this is one of these places where having the naming convention, all I have to look for is the capital letters to look for the names of the states, whereas all of these are in lowercase, so it really allows me to quickly zoom in on the states. Okay? Okay, so item dot weight state chart. We're going to ask whether they're obese, we have to ask their state chart that has to do with obesity. We have to ask it, okay, is this certain state of yours active? And this is the name of the state, person.obese. Now let me put this up on the big screen, and you folks could see it, okay? So there you go, okay? So this is a reference to the person, and we're saying, hey, for you person, for your weight state chart, which is after all the thing that keeps track of whether they're obese or not, is this current state active? Okay? Yeah.
In the parameter to the state active function, can we also use item.produce because we're referring to that particular individual?
No, because this has to do with it's not a question of whether that particular individual has a thing called obese. It's person that has this category of weight called obese. And so it's not their current state, it's sort of obesity with respect to person. Does that?
So it's treating that parameter as a class, whether it's in that particular category of
no, this is actually a name for the state. So person.obese, it's actually, if you look at it at a technical level, it's a short int. Just a name. It's a name for. Yes, yeah. It's a specific value that denotes this state of being obese. Okay. So, folks, if we run this now, we can run this, and what we'll see here is in the population. Let's click. Whoa! Oh, that was exciting. Okay, fraction obese. 16%, 17%, 16%, and of course it's cumulative occurrences of overweight is shown up there. So this is how you can keep track of the fraction of a population that matches some criterion. You total up this for all people who match the criteria. You total up 1 divided by the population size. Now, you notice that I snuck something in there that I'd prefer not to have to talk about. Put this over my head or something. And yet it occurs again and again and again. And I'm sorry I have to talk about it. I'll block the door. And okay. So you'll notice I put this 1.0 here. It turns out if you leave out 1.0 here, let's run it now. Looks great, right? 1 over the population size. I'm sorry to have to tell you this. 0. There's no, wait, but there's all these obese people. It's 0. Guess what, folks? Java sometimes is a bit too flexible for your own good. And one thing is, it's arguable whether this is the case here, but it's doing what's called integer division here. It's saying, okay, Population size is a count. It's an integer. It's like 99 or 57 or 100 or what have you. And it's dividing. If you just put 1 divided by population size, it's dividing the 1 as an integer by 100 as an integer, and it's saying, oh, 1 divided by 100 as integers is 0. 50 divided by 100 as an integer is 0. 99 divided by 100 as an integer is 0. 100 goes 0 times into 99. 100 goes 0 times into 50. And that's not what you want. 99% of the time you don't want that. So you have to say, do it as 1.0 divided by this thing. And that will actually perform a computation in the way that you want it, which is a division as floating point division. And 99 divided by 100 would be 0.99. 1 divided by 100 would be 0.01. Rather than this whole thing of asking how many times does 100 go into 1, 0, well, we'll call it 0. So you got to be a bit careful with that. When you have divisions, if you have values that are not doubles, you need to make it clear that they're doubles. In this case, it's particularly easy because I have this 1.0. Okay. So that's good in an uncomfortable sort of little factoid there. Any questions on that? Yes. Yes. Yeah. 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 So in other words, can we eliminate them from the population? Yes. And we're going to be seeing how to do that maybe at the end of today, maybe first thing tomorrow. Okay.